All light is made up of both electric and magnetic energy. That electromagnetic energy behaves like a wave. And if I were to demonstrate a wave's properties with a rope, we can see that waves have a few simple characteristics. For the sake of simplicity, think of wavelength as the distance from one high peak to the next high peak. Amplitude is how tall the peak is. Polarity is the angle of the wave. For example, up and down, left to right, or in all directions. Visible light is all of the light whose wavelengths fall between around 390 nanometers to 740 nanometers, with a nanometer being 1/billionth of a meter in length. All the light in this range, from purple to red, are called the light spectrum. And we can see the light spectrum naturally occurring in rainbows. You will be interested to know that wavelength determines color. As examples, 450 nanometers is seen as blue. 540 nanometers is seen as green. And 720 nanometers is seen as red. The amplitude, or the height, of the wave determines the brightness or intensity of that color. Now, I would imagine you're probably wondering about white light. White light is what you get when a light source is emitting all of the visible wavelengths of light at the same time. We know if we take a prism and split a beam of white light, we get all the colors of visible spectrum. And we also know that we can combine these colors to create white light once again. In 1905, Albert Einstein was able to prove that when you exposed metal to a certain frequency of light, that metal would give off electrons. This contradicted the wave theory of light, and Einstein suggested that light also behaved like a particle. Because light behaves as both a wave and a particle, scientists today describe light as a bundle or a packet of photoelectric energy called a photon, which moves at about 300,000 kilometers per second. That's really quick. So a question you might have is, how is light created? Without getting into too much detail, there are two types of light we will note here: incandescence and luminescence. Incandescence is when something hot gives off light. The sun, hot iron, and incandescent light bulbs are all good examples of this. The way it works is that when atoms are heated, they begin to vibrate and move. When certain atoms get very, very, very hot, some of this heat energy is given off as visible light. Because there are many types of reactions going on when an atom is vibrating due to heat, there are different wavelengths of light being emitted. Luminescence is when light can be generated without heat. We see luminescence in fireflies, in glow sticks, in fluorescent light bulbs. Luminescence occurs when an electron of an atom has been energized temporarily to a higher than normal energy state, only to have it fall back down to its original normal state. When the electron falls to its lower original state, energy is then transferred in the form of light. Because specific atoms have specific electron energies, this light is given off as a specific wavelength of light, creating a specific color. We see this when phosphors of a TV screen are bombarded with electrons, for example. There are a few different fates of light: transmission, absorption, and reflection. Transmission is when light passes through one medium into another. It can be air, glass, water, certain kinds of plastic. Light passing through a light bulb or a flash unit is a good example of transmission. It is very important to note that light travels at different speeds when moving through different materials. For example, light travels much more quickly through air than it does through water or glass because water and glass are much more dense. Now, if a photon travels from one medium into another at a perfectly straight 90-degree angle, it will go through that new medium in a perfectly straight line. This is called direct transmission. When light moves from one medium, such as air, into another medium, such as water, at an angle, this changes things. Because water is much more dense than air, the angle of light will actually bend as it's hitting the water. This is called refraction. Subjects photographed in two different refractive mediums simultaneously will appear to be distorted because of this optical bending of light. This particular characteristic of light is critical when considering photography, as it allows our curved lenses, which are made of glass, which are much denser than air, it allows our lenses to bend light and steer them to our sensors, where we're able to capture this light energy. Diffuse transmission is when light is able to pass through material, but it is also scattered in the process. A diffuser over a flash is a good example of this. When I say reflection, what I really mean, it's when light strikes something and bounces off. And we're going to be talking about this much more in the video. Absorption. Light can also be absorbed in different ways. Pigments are molecules which are really good at capturing light energy. If most of the light hitting an object is absorbed, we see it as black. When equal amounts of wavelengths are absorbed and equal amounts of wavelengths are being reflected, we see this as a shade of gray. When no or little light is being absorbed, we see this as white. An important note here is that when incandescent light is completely absorbed, things tend to heat up very quickly. Now, what about color? When white light strikes an object, such as a blade of grass, different wavelengths of the white light are absorbed by certain plant pigments. For example, grass is green because all the wavelengths of light are being absorbed with the exception of the green wavelength. Red and blue light are very important to photosynthesis, and green is pretty much useless, and therefore it's reflected and we see it as green. The same can be said with other colors that we see as a result of reflected light. Some of the wavelengths are being absorbed and other wavelengths are being reflected. And this is what causes our eyes to see color. I know I've thrown several hundreds of years of scientific research at you, but in summary, light is electromagnetic energy that behaves as both a wave and a particle. Wavelength determines color. Amplitude determines the intensity. Light can be created by incandescence, which means from heat, or luminescence, which is non-heat light creation. Light can pass through certain materials. This is called transmission. When light passes through two different materials at an angle, a bending of these light rays occurs. This is called refraction. White light can be partially absorbed and partially reflected to give off color. If you found this video helpful, you may be interested in my new DVD, Lighting Crash Course, where I will teach you one of the most effective, comprehensive courses on portrait and product lighting available anywhere. You can order it from the following link.